Okay, Assalamualaikum warahmatullahi wabarakatuh, and hello students. So this is the last part in Matrices 5.5, system of linear equations. So what is system? System is a group of entity or object, real or abstract, comprising a whole with each and every component or element interacting or related to one another. So example of a system: a solar system, your blood system, your computer system, etc. So what is system of linear equation? System of linear equation is as written, a11x1 plus a12x2 plus until a1n xn, then it is equals to b1. And then you have another equation, a21x1 plus a22x2 plus until a2n xn, then it is equals to b2. And then you have another equations up until bm. So actually this all system of linear equations can be written in matrix form, as you can see in this slide. So all the A becomes A11, A12, so we call this is your matrix. Okay, so all the A becomes A11, A12 until A1n, and then another rows A21, A22 until A2n, and then up until m rows and n column. Okay, so this is matrix A, this is matrix X, or x1, x2 until xn, and this is matrix B, your b1, b2 until bm. So you have ax equals to b, right? Written in terms of matrix form. Okay, how can you write this in terms of matrix form? Okay, you may recall back multiplication. Okay, so if you multiply this row with this column matrix x1, okay, then you will have a11x1, which is a11x1, plus a12x2, a12x2 until a1n xn, a1n xn, and everything is equals to b1. Like this row, okay, if you multiply with this column, then you will get am1x1, which is this one, am1x1, am2x2, am2x2, plus until amn xn, amn xn, and this one is equals to bm. So that's why this system of linear equations can be written in the matrix form as this one. Okay, so there are few ways to solve the system of linear equations. What you have learned before this, I believe you know about simultaneous equation, right? Okay, so there is one example of system of linear equations. Okay, however, in this one we have several equations, okay, up until 3 by 3. So in this matrices chapter, we will learn two methods, which is first solve using inverse matrix, and then later we will learn how to solve using Cramer's rule. Okay, so if you solve using inverse matrix, you have to remember it will become this one. Okay, you have changed your system of linear equation into matrix form just now, right? Okay, so from this matrix form, if I multiply A by its inverse, then we'll have I. I is what we call identity matrix. Identity matrix is where your leading diagonal is equals to 1 and everything else is equals to 0. Okay. So when I times A inverse with A, multiply A inverse with A, I will get identity matrix. Okay, and if you multiply A inverse to the left hand side, then you should multiply A inverse to the right hand side as well. Okay, so identity matrix times multiply the any matrix, then it will become the matrix itself again, because it is identity. Okay, So x will be equals to A inverse B. So to find the value of x is the x1, x2, x3 until xm. Then you will have to find the inverse of A, then multiply with your B. Okay, so let us see this 2 by 2 example, 2 times 2 example. So you have 2x minus 5y equals to 15 and 3x plus y equals to 31. So this system of linear equation, if I change to matrix form, I will have 2, negative 5. Okay, just look into the constant. 2, negative 5 here, and then 3, 1 here. Okay, and then this is your B. So your x is now xy. Okay, so this is your A, x equals to B. Now we have to find the A inverse, because x equals to A inverse times B. So A inverse is if 2 by 2, then it is 1 over determinant, then the adjoint A, which is D, negative B, negative C, A. So you have as this one. Okay, the A and D change places, the B and C change sign. Okay, and then this determinant is AD minus BC. So your x now is A inverse multiply with B. So this is your A inverse from your answer just now, times with 15 and 31, which is your B. They will get 10 and 1, which is your x is equals to 10 and your y equals to 1. Okay, another examples of the system of linear equations by using inverse matrix method. Okay, so this is a system of linear equations. As we can see, it is in 3 by 3 matrix. Okay, so you put the system of linear equation into matrix form, then we'll get 1, 1, 1. There's no x here, so 0x, 2 and 5, and then 2, 5, negative 1, everything equals to 6, negative 4 and 27. Okay, so again, x equals to A inverse B. And then the A inverse equals to 1 over determinant of adjoint A. So to find the determinant, okay, if you still remember, there are 2 ways to find the determinant for 3 by 3. The first way is diagonal expansion method. And then the second way is this one as a minor and cofactor. So in this question, it used minor and cofactor. So it expand minor cofactor from the first row. So you have A11, A12, A13. Okay, so what is your first row? Your first row is here. So the sign is plus, minus, plus. So plus, minus, plus. Okay, 1, 1, 1. Okay, and then again you have to remember how do you get this matrix, how do you get this matrix, and how to get this matrix. Okay, if you don't remember this one, please go back to our previous video. So the answer is negative 31 for determinant. So we have to find adjoint A for 3 by 3. So the adjoint is actually a cofactor transpose. Okay, so you find it this way, and then the sign, don't forget, plus, minus, plus, minus, plus, minus, plus, minus, plus. This is the cofactor sign, and then there's transpose right here. Okay, and then this answer you transpose to find the adjoint. So this is your determinant A just now, negative 21, and this is the cofactor transpose Okay, so this row or this column will become your row, and then this column will become the new row, and then this column will become the new row in your adjoint. Okay, so you have find your A inverse, then you multiply with your B, then you'll get the answer 5, 3 and -2. Okay, so this is example. Solve each of the following system of equality by inverse matrix. So let us solve A, B, C and D. I will solve A for 2 by 2 and you do B, and then I'll solve C for 3 by 3 and again you do D. I will give you as the answer later. Okay, for this one, okay, this is actually 2x minus y, yeah, 2x minus y. Okay, so let us solve these problems. Okay, so this is the question A just now. 3x minus 2y equals to 6 and 5x plus 4y equals to 8. Okay, so this system of linear equations consists of two equations. We change to matrix form, then we have 3, -2, -5, 4, and the x matrix is xy, and the B matrix is 6 and 8. Okay, so you have here your Ax equals to B. Okay, so remember to find x, then you have to perform a operation of A inverse multiply with B. So we find our A inverse here. Okay, so this is your A inverse, then your x will be equals to your A inverse times with B, which is 6 and 8. Which is then you'll get your answer 20 and 27. Okay, so to check whether your answer is correct or not, then you can substitute back this value of x and y. So this is your x, this is your y. Substitute into your matrix or your system of linear equation. Then if I put 3 times 20 minus 2 times 27, I will get 6, and -5 times 20 plus 4 times 27, I will get 8. Okay, so that's how you can check whether you get a correct answer or not. Okay, so this is question C. I will give you answer to B and D later after this. Okay, so this is question C. X plus 2y minus 2z equals to 1. 3x plus y minus z equals to 2, and 2x minus y equals to 3. Okay, so we change into matrix form first, then we'll have then we perform operation to our matrix A to find the inverse of it. Okay, but remember this is 3 by 3. Okay, there are two ways to do the to find the determinant. So for example, I choose to expand use the diagonal expansion method. Now I have to find the inverse. However, before that, let me find adjoint A first. Okay, so remember adjoint A is the perfector transpose. Thus your x is okay, so you find your x equals to 3/5, -9/5, and -2. So you may check your answer. Substitute each of the x, y, and z into this and get the answer equals to 1, equals to 2, and equals to 3. Okay, now I give you the answer for B and D. This is example from the final exam 2016-2017 first semester. Okay, ABC Scholarship Academy receives a gift of 7,000. The money is then invested in stocks, bonds, and certificate of deposit (CDs). Since CDs investment is insured by Federal Deposit Insurance Corporation, the Academy invests in CDs 1,400 more than the investment in stock and bonds. The interest for all type of investment is tabulated in table 1. So you have stock 7% interest, bonds 5% interest, and CDs 3% interest. At the end of the year, the investment gives Academy an annual income of 286. This situation can be represented by x plus y plus z, okay, in which x, y, z is stocks, bonds, and CDs. So I have x, which is stocks, y is bonds, and z is certificate of deposit, which is CDs. Okay, so the money 7,000 invested in all three, so x plus y plus z equals to 7,000. And then it said the Academy invest in CDs 1,400 more than investment in stock and bonds. So z equals to 1,400 plus x plus y. Okay, and then for the interest, okay, 7% stocks plus 5% bonds plus 3% CDs give a total of 286 for the year, at the end of the year. Okay, so in matrix form, we can write this in terms of so this one is actually we change first to negative x minus y plus z equals to 1,400. Okay, so we get negative 1, and 1 equals to 1,400. Okay, so you solve for this one and you get the answer x equals to 1,000, y equals to 1,800, and z equals to 4,200. Second method to solve for the system of linear equations you will learn is Cramer's rule. Okay, so for the Cramer's rule, you will change the column for each column to the answer to the matrix B. Okay, so for example, column 1 we change to matrix B. Each column will be changed to matrix B. So A1 means column 1 changed to matrix B. A2 means the column 2 be changed to matrix B until you have AN. AN means you have A11, A21 until AM1. Okay, and then your last column will be changed to B1, B2, BM. Use inverse matrix and Cramer's rule to solve the following system of equation. Compare your answer. So I will do Cramer's rule and you do inverse matrix. Okay, so this is example for the Cramer's rule just now. You have x plus y minus z equals to 0, 2y plus z equals 7, and x minus z equals to negative 2. So first of all, we change this system of linear equation into matrix form. Okay, so before anything, if you still remember to find the Cramer's rule, using Cramer's rule, then you have xi equals to the determinant of ai divided by the determinant of a. So let's find determinant of a first. So this is our a. So again, let me use a diagonal expansion method to find the determinant. Okay, now let's find the determinant of ax. Okay, so what happens here is, if you see the first column associated with the variable x, second column with variable y, and the third column with variable z. Now if I want to find ax, I want to find the value, the determinant of ax, then I change my first column to b, only the first column to b, and the rest is the same. Second column is the same, and then similar for the third column. Okay, you only change the first column to b because all the first column is associated with the variable x. And then to find the determinant, again I only use the diagonal expansion method. Then I will have which is equals to 1. Okay, let me find ay first before I told you what to do next. So for ay, change all the column number 2 to your b. So this is how you do Cramer's rule. Okay, and then again to find the determinant, just expand. Okay, so lastly, let us find az, in which we will change column number 3 to the B matrix. Then again, to find the determinant, just expand. Zero, 0 against 0, then we have equals to 3. So to find x is actually ax, determinant of ax divided by determinant a, which is, we have 1 here and another 1 here. So 1 over 1 equals to 1. Okay, and then for y, it is determinant of ay divided by determinant a, which is we have 2 over 1 equals to 2. And lastly for z, it is determinant of az divided by determinant a. And then our z, we have 3 divided by 1, it is equals to 3. Then you have x equals to 1, y equals to 2, and z equals to 3. Again, you may check your answer. So how to check your answer? You just substitute the x equals to 1, y equals to 2, and z equals to 3 into this one. Okay, did you get the answer? 0, 7, and negative 2 means the value of x equals to 1, y equals to 2, and z equals to 3 is correct. So that's how you use Cramer's rule. Okay, you just substitute each column associated with each variable to matrix B. An example, Nadal, an exchange student from Brazil, made phone calls within Canada, to the United States, and to Brazil. The rates per minute to these calls vary from different countries. Use the information in the following table to determine the rates. Okay, so in September, he calls from Canada to US to Brazil. Okay, 90 minutes to Canada, 120 minutes to US, and 180 minutes to Brazil. So we have here Canada will be represented by P, while United States will be presented by Q, and Brazil will be presented by R. So we have 90P plus 120Q plus 180R is equals to 252. And in October, we have 70P plus 100Q plus 122R plus 120R equals to 184. And in November, he calls again to Canada for 50 minutes, to US for 110 minutes, and to Brazil 150 minutes. And it cost him 206. So we can write this in terms of matrix form. Again, which will get 90, 120, 180, 70, 100, 220, 50, 110, 150. Or you can have this table, okay, directly as your A. And then P, Q, R equals to this table, then will be your B. 252, 184, and 206. Okay, so please solve this one using Cramer's rule and find the answer. 40 cents per minute for P, 60 cents per minute for Q, and 80 cents per minute for R. Okay, that's it for our chapter 5. Okay, we have finished 5.1 until 5.5. Okay, you may repeat the video if you don't understand any, or you may ask your lecturer. Okay, and please do all the exercises. After this, do the supplementary exercise and have a discussion with your lecturer. Thank you, students. Good luck.